So hello everyone. I would like to show you guys how to. I would like to show the Couchflix demo and how it works, and how to run it, and maybe explain a little bit of the code. So first of all, Couchflix is designed to show most of the features of Couchbase with full text search. And then I basically created a Netflix-like search feature. So everything you need is already in this project. I basically exported the IMDb database, and it's here in the data. We have two data sets, one with all the movies, and the other one is a data set with all the usernames, the actor names. So basically, it's very simple to start this project. Basically, you clone and open on IntelliJ. Here is the project, is the whole project. You see, we have here the whole source code and the data you need, the data sets, and also the front end of the application. It's the front end just a simple HTML, so it's a very simple project. So to run it, all you have to do is, of course, clone the project, and then you will unzip the data and run these two commands to import the data. From here, of course, I expect that you have a data set, a bucket called movies, and of course with the administration and password here. So this is what I have. Here I already created the movies bucket here, and I already imported the data because it takes a while. As you can see, we have 40,000 movies here, and 207 actors names. So, and then the next step here is to, of course, create one of the indexes. So this is the other ones. The other index that we use in the code is a very simple index. So just come here and add bucket and create. Sorry, just come here to search and add the index and create a very simple index. But this one is a more complex one. So here, this movie shingles. There's a lot going on here, and this is most of what the talk is about. How to create the right indexes for your application. Okay, and then once you have done this, and here I'm also using this is my application. So here and the resources application dot properties, I have the connection I'm using. So I am also create a user called movies. And this user also has the password set as password. So once I have done that, all I have to do is to run mvn spring boot run, and this will start our application. If we come back here and open the front folder, we have here Couchflix HTML. And then I can open this, I can basically copy the path and open here on Chrome. And this is already, the initial page is just a pure HTML with jQuery. That's the application's already running. So now, if I search for, let's say, Star Wars, I'll get Star Wars movies here. So we already have fuzzy matching. So if I search Star Wars, I will still get some results. If I search for Star Trek, Start track. It's a better example actually. So we still understand that we still have this fuzzy matching. So we will bring the best matches for this result. Some of the features here. First, Star Wars. So some of the features is, first you can see exactly why this movie is the first result. So once you click, of course, we bring the description, we have the database. Here I basically search for this term on Google and bring the very first result. So I don't know what's going to show here, to appear here. It's just a very simple search to make things cooler. But well, please ignore this feature. You can even disable if you want to. But first, we have the description here, and once you click in the movie, you can see here why this movie appears as first. So it has the highest score, and here are some of the fragments that we matched, and that's why this is the first result. So of course we can click, let's say Rogue One, and then scroll here and say, hey, this is Rogue One. And then those are the matches that we had. If you come here and say, I don't know, some other movie here, let's say Eworks, and then scroll here, and oh, here is the Ewok movie, and that's why this movie is being listed here. You can enable explanations, but usually I turn it off because it just returns too much data, and it's actually it makes it a little bit difficult to understand what's going on here. So I just turn on explanation just when I want to show it, but usually in my code it is set to false. Some other features here is let's hide this data, is I also have facets here. So this is a very simple facets. So I can say, let's say Star Wars comedy, and then I will bring only movies which genres is comedy and has some kind of Star Wars on it. And as you can see, the only two real Star Wars movies related is like kind of, we also have Family Guy here. So that's basically some of the things we can do with genres. So in this case, we can also, let's say now, well, action. So pretty much every single Star Wars movie is about action. And of course, we can say Star Trek here. But another thing that I think is interesting is whenever you click a movie, I print the whole document here, so you can explore and understand, okay, what's exactly we have, which data we have in this movie. So in this case here, Star Trek, we have budget, cast, and here is a huge list of actors and the cast, collection. So this is basically a movie that it's part of a collection. The whole crew, and you see 107 items here, genres, what else, original title, production companies, spoken language, stars. So now this is more like for me to show this, those are real stars. So this is more for the front end. And we have a vote average, vote count, and all those data. Okay. And another feature here is you can also search for actor's name. So let's say I search for Bruce Willis. So what happens here is we actually identify that this is an actor, and then we change all the rank factors to boost movies with this actor name. So that's why we don't have a movie called Bruce. So probably if I search for Bruce here, you see there is movies called Bruce, or They Call Me Bruce, or Mary and Bruce, and My Name is Bruce. But when I say, hey, Bruce Willis, it actually show only Bruce Willis movies. And if I say just Willis, yeah, there's not even Willis here. So our code actually understands that this is an actor. I can show you some of the code. So basically the code is designed to be something that you start with a very simple search. So here in the search example, you can basically comment this and say, hey, return search one and the phrase. So this is the first implementation, and then at some point, and then you can basically do the same for the other versions. So this is a very simple search. I'm using the movies all index here, which is basically a movie index that index the whole database. And the problem with this is we bring a lot of bad results. And then I basically showed the developers, hey, this is not about matching. This implementing search in your application is about how you bring the most relevant result. Because if you come here and say, I don't know, maybe comedy or something, I will try to to bring the best results I have about this topic. Let's say Lord of the Rings, right? Let's see if I have Lord of the Rings. I don't have any Lord of the Rings in my database, that's why. So let's try, yeah, Star Wars. I'm actually trying to bring you the most well-rated movies according to the database itself. So it's not just about matching itself, it's about returning the best result. And here in the code, what we do is, first we start with a very simple index, and if you try this, you see that this doesn't bring very good results at all. And then by default, when you search for something, we will search in the all field, and this all field is basically putting all the text in a single field and searching on this single field, which has all the content of the document. And as you might guess, doesn't work that great. And then we start changing here the implementation. So here's the second implementation where I already have I search for the title, and I have a dejection query here. So a dejection query, in this dejection, I basically say, hey, yes, I support the fuzziness level of 1. So if someone come here and say Star Wars and Star Wars, they both will have very similar results. Then, of course, this is, by the way, this is the last implementation. So this is search 11. Search 11. But basically the code goes on and it goes on, and I add more fields, and then I add boosting, and then I add some other. I basically also get I search on the actor's name, on the crew. So if I search for Steve Spielberg, it will also find some Steven Spielberg movies. I also have here, I also boost for other fields. So let's say here, boost for release years. This is I'm trying to emulate here some kind of graded boosting I actually forgot the name, but basically what I'm trying to do is A movie which is which was released in 2019 is of course something important compared to is an important feature compared to a movie released in 2017. But I don't really care if a movie was released on 2000 or 2001, right? So what I'm trying to do here is to, hey, if the movie is really new, yeah, boost the movie. If the movie is old, yeah, try to penalize the movie here. So this is basically what I'm doing here. So if the movie is up to 4 years old, I boost in 35%. If the movie is up to 10 years old, in 15%. If up to 15 years old, don't boost at all. And if it's more up to 25 years old, then penalize in 88%, and so on and so forth. Kind of same thing for runtime. I also have a rating, a weighted rating. So basically, I mix weighting with vote counts because there is always this problem with yeah, what is better, a movie with a 5 stars rating and 4 votes, or a movie with 3.5 stars and 4,000 votes. So there is some math formulas around that. So how you can actually put those mix those two numbers in a proper way, and that's one of the things I'm doing here. You can actually see this in, there's another there's some code here that actually does that. So yeah, not here. Score calc. So that's exactly what we do here. So this is the formula, and those are some real use cases. What else? That's pretty much what the code does. At some point here, we also have on search 11, we also have a query entity extractor. So basically, this entity extractor will get your query. So one of the things we can do here is say, hey, Bruce Willis comedy. Willis comedy. So we understand that this is an actor, and we understand that this is a category. So how we do this is pretty much text matching. So we have all the list of actors in our database, and we try to match this with our list. So we basically have a key value. I have all the documents there, and the key of the document is the name of the actor. So I match the name we have here with the name I have in the database. And also I try to match and say, hey, do we have any genres in the query? And if we do have this, we basically return a map with the entity types and the strings we recognize. So in this case here, I say Bruce Willis. Let's say another movie here. Favorite. So you see that this is the first result because we extracted this, we identified this as an actor, and here we search. Hey, this I didn't recognize this, so I'm just going to search this string here on the database and boost the actor name. So that's basically how we play with entities. And of course, in our code, let's go back to search. And in our code, we know, hey, this is if this is an actor, let's say here conjunction query. If this is an actor, if we have a person in our query, we use a different boost value. So here we don't, in some case we boost by 15% if we don't have an entity there, and if we have an identified entity in the query, we boost the cast name by 50%. And that's how we kind of adjust the queries. And of course, if we have any other fields, we kind of adjust the fields according to what we have defined in the code, what we have identified in the query actually. So that's pretty much example. If you have any questions, feel free to reach me out via or Gmail or email or on GitHub itself. And well, thanks for watching.